In today's question, I am going to calculate the course and distance between two given positions using both plane and Mercator sailing. So this will teach you guys about the difference in plane and Mercator sailing if the positions are located at about say 600 nautical miles. The reason to do so is that plain sailing is used up to 600 nautical miles because it assumes that the earth is flat, and Mercator sailing is used for distances greater than 600 nautical miles. But what if it's about the range of 600 nautical miles? Which course and distance should we use? Is there a difference? Why the number 600 nautical miles is used? It's just an average number taken. So books describe the distance as anything from 400 to 800 nautical miles. So 600 nautical miles is a number that is arbitrarily quoted. But today we'll learn what is the difference if I calculate the course and distance using both plane and Mercator sailing. So let's get into the question here. The question says that you have to find the course and the distance between the positions given to you using plane sailing first. So the positions are given as A and B. A is of course the departure position and B is the arrival position. So I can write that down here. This is the departure position and this is the arrival position. And you also have to find the course and distance using Mercator sailing. And then decide which course and distance would you employ for your voyage, or would you choose for your voyage, and why would you do so? Alright, so let's get started. So I've been given the two positions, 27 degrees 11.7 minutes south, which is position number A, and 176 23.6 minutes west. So I will just draw it no, because I have idea where it is, but you can draw it anywhere here, and you can draw the position A first. Draw the position A. The horizontal line is of course the latitude and the vertical line is the longitude, and write down the position here, 27 degrees 11.7 minutes south and 176 degrees 23.6 minutes west. Alright, from here you have to go to 36 degrees 9.8 minutes south. So that would mean that you have to go further south from here. So you will be going down south from here. You will be going south, and you also have to go 176 degrees 23.6 minutes east. Now where would that lie? Now you have to remember that 176 degrees is very close to the anti-meridian. What is the anti-meridian? The anti-meridian is 180 degrees, which is on the other side of the world. So our Greenwich meridian is 000 degrees. That is the meridian that passes through the UK. And the anti-meridian is on the opposite side of the globe, which is 180 degrees. So as we go west and east from Greenwich meridian, we go on to the other side of the world. So basically we are coming from the other side of the world. The other side has 000 degrees, if you can visualize it, and we are coming from the other side here. So this is about west and this becomes east. So imagine facing 000 degrees, right? So as you come around, your 176 degrees west would be somewhere here and 176 east would be here. It would be the opposite of what you would have if you were facing 000. So if you face 000, on your right side is the east side and the left side is the west side. But as you go around the world and you turn around and face 180, the west and east reverses. So I should be writing east here, not west again, sorry. So it reverses in direction. So you know that you have to go south and you have to go westwards to reach your position. Position B would be somewhere here. Alright, so this course becomes a southwesterly course. This is the course angle given by theta. This is course. Alright, so drawing the diagram is very important for you guys to be able to visualize what is going on. Alright, so only when you can visualize, you can work on the calculation. So this vertical distance between the latitudes of A and B becomes d lat. The horizontal distance between A and B, it becomes the departure. This is not Dlong, this is departure. I have explained this in my previous videos. The link to those videos are in the description section below. Please make sure you watch it if you haven't so already. And of course the distance that separates A from B is known as the distance. This is the distance we have to traverse on the ship to reach position B from position A. Alright, So once we are very clear with what direction we are going in, let's start calculating the dlat and dlong. So we have the latitude of A and B written here, and so is the longitude. So let's start calculating the dlat. Now the rule for dlat is same names you will subtract and different names you will add. So same names, that means if both are south, you will subtract it. So you will subtract the smaller number from the bigger number. The answer is never negative. So subtract 36 degrees 9.8 minus 27 degrees 11.7. You will get 8 degrees 58.1 minutes. Now dlat is always named in the direction of travel. So you from 27 degrees south you are going to 36 degrees south. So you are going south direction. So you will name your dlat south. Also you can calculate it in minutes. So you have to convert it into minutes. So how do you convert dlat, which is in degrees and minutes, into minutes? Multiply the degrees by 60. When you multiply the degrees by 60, only multiply the degrees by 60. So 8 multiplied by 60 will give you 480. And then you add this minutes to it, because this is the remaining minutes, isn't it? You add this remaining minutes to it, 58.1. So 480 plus 58.1 will give you 538.1. So you write down 538.1 minutes here, and this dlat is still south, of course. Alright, with dlong what happens is different names add. So you have west and east, so you will be adding the two. And from west you are going to east, so you would think you are going in an easterly fashion, in an easterly direction, right? Normally when we say we go from west to east, we say we go in an easterly direction. So you add the two. But dlong can never be more than 180. It can never be more than 180 degrees dlong, because longitudes are not more than 180 degrees, right? So as soon as you see it's more than 180, you will subtract it from 360. Alright, and what you get is 360 degrees. So in your calculator put 360 degrees first, minus 352 degrees, 47.2 minutes. So 360 degrees minus 352 degrees, 47.2 minutes. You should be getting 7 degrees 12.8, right? 7 degrees 12.8 minutes. But as soon as you subtract it from 360, reverse the notation of the dlong and make it west. And this is what we saw in the diagram. We are actually going in a westerly direction. From A to B is actually going west, right? So you have to convert the dlong also into minutes. So you will multiply it, the degrees, by 60. 60 multiplied by 7 is 420, plus 12.8 is the remaining minutes, which you get is 432.8 minutes. And again it is of course west. Now that you have your dlat and dlong, you have to calculate your mlat. Your mlat stands for mean latitude. Mean latitude is basically finding the mid position between A and B. Alright, so because we cannot use either the latitude of A or B for our calculations, we use a midpoint. The midpoint is somewhere here. Let's say this is mlat. Alright. We have explained why all this is so in my previous videos, so make sure you watch that. So to calculate mlat, if they are both the same hemispheres, that is both of them are south or both of them is north, you will just add the two and divide by 2. So you add the two latitudes, latitude A and latitude B. Just add the two and divide by 2. So you add 27 degree 11.7 minutes to 36 degrees 9.8 minutes. So once you do that and you divide it by 2, the answer you get is 31 degrees 40.8 minutes. And of course it's south because your both latitudes are in south, so the point in the middle of them will also be in south. Then you move on to departure. Departure, the formula for departure is dlong multiplied by cos of mlat. You have your dlong as 432.8, always use minutes. So when you see dlong is not preceded by a sine or cos or tan, always use your dlong in minutes. So your dlong is in minutes, you will use it in minutes, 432.8 multiplied by cos of mean latitude that you have just calculated above. Simply put that in your calculator and you will get your departure as 368.3 minutes. Departure is a unit of distance, so the answer is always in minutes. It's never in degrees. Alright, so when I tell you all these things, make sure you make a note of it. So when you're working out these calculations, you should remember the units of each of the value. Alright, that's what maths is all about. You should always know the units of the values. Once you've got your departure, the other formula is tan of course equals departure by dlat. Now, if you go back to the figure, you don't even have to round these formulas. If you can draw this figure, then it's simple plain trigonometry. You've got a right angle triangle here. You can simply use your sine, cos and tan and find out the values. Alright, I have discussed all this as well in my previous video. Make sure you watch it. So tan course is departure by dlat. You know the value of departure. Departure comes from here. Dlat you've calculated above. Tan course will equal 0.68441. This is what you get when you divide these two values. Take tan to the other side, becomes tan inverse. In your calculator, press shift tan. You will get a tan inverse and then put in this value here and you will get the course as 34.4 degrees. Now here it cannot be in minutes. The answer will be in degrees because courses cannot be in minutes, right? As soon as you get 34.4 degrees, you know that you cannot steer a course of 34.4 degrees on the ship. So you can round it off to the nearest number, which will be 34 degrees. So I have rounded it off, okay? Round off. You cannot sail in decimals of minutes. Now, of course, depending on your lecturer and what he has taught you, you can do what your lecturer tells you to do. But here for me, I think I work what you would do practically. I use the same principle. So, of course, I will use the rounded off course. And the rounded off next number is 34 degrees. So that is why this is 34 degrees. Now I have to name my course. Now I'll name it south 34 degrees west. Why is that? Because I was going in a southwest fashion. Or you can say this is comes from dlat. Whatever you name your dlat or whatever you name your Dlong, south 34 west. Also in my figure here, I can see that I am going in a southwesterly direction. My course is southwest. Right? So as soon as I write south 34 degrees west, I have to calculate the true course. So what is south 34 degrees west? Well, if I draw north, south, west and east, I know my west is 180 degrees and my south is 180 degrees and my west is 270 degrees. South 34 west means I am going from south towards west by 34 degrees. So this value is 34. I will add 34 degrees to 180 and get my course of 214 degrees true. 180 plus 34 is 214. That is my true course. So that's why my true course is 214 degrees true. So I've calculated my course. All I have to do is now calculate my distance. So the formula, again going back to the plain sailing diagram, is cos of course equals dlat by distance. I know my dlat already. The course I can use 214 or 34. It doesn't matter. I'll get the same answer. I will get a negative sometimes, but I can ignore the negative sign because distances cannot be negative, right? So dlat cos of 214 or 34, it doesn't matter, equals dlat, which is 538.1 divided by distance. I will take my unknown to one side, bring my known to the others. So my unknown was distance. Distance becomes equal to 538.1 divided by cos of 214 or 34, doesn't matter. In one case you will get a negative answer. So 538.1 divided by 0.82903 will give you 649 minutes or 649 nautical miles. That's my distance. So I know that I have to steer a course of 214 degrees true and travel a distance of 649 nautical miles if I am using plain sailing. I have got half of the answer already. Now I have to find the same course and distance using Mercator sailing and see the difference between the two. So I'll start with my Mercator sailing. I will not draw the diagram and all that again, but remember the diagram will differ slightly. Why is that? Because in my previous video I've explained it. I don't want to explain it again, but I'll quickly show you the drawing here. So this is your A and this is your B. Now of course this is distance and it remains the distance between A and B, right? In plain sailing this is a dlat and this is departure. But what happens in Mercator sailing is we extend this triangle a little bit more. The horizontal distance then becomes Dlong and the vertical distance becomes DMP. That is the difference in the meridional paths. I'll show you how to calculate that. Alright, so let's get started. We do the same thing again. We write down the latitude and longitude of A and B. Different names, you will subtract it. You will convert it into minutes again. 480 plus 58.1 gives you 538.1. And similarly, you will add these in the Dlong section. Because it's more than 360, you will more than 180, you will subtract it from 360. You get your Dlong in degrees and minutes, convert it, you get 420 plus 12.8, and you have converted it into minutes, and you have named your Dlat and Dlong. Alright, it's the same as plain sailing. The only thing that's different from plain sailing is that you have to calculate what is known as meridional paths, and meridional paths are calculated from the Norris tables. Of course, Norris tables, right? So I'll show you where to go into. So you go into your Norris tables in the relevant section of meridional paths, and you have to calculate the meridional paths for both the latitudes. So first we'll calculate it for 27 degrees 11.7 minutes, which is latitude A. So your latitude A is 27 degrees 11.7 minutes, which lies somewhere between 27 degrees 11 and 27 degrees 12 minutes, right? So what I'll do is I'll go into the nautical almanac, and you can see here the nautical almanac, the page of meridional paths is opened for me. So from here you can see that on the horizontal side you have the degrees, and the vertical side you have the minutes. Alright, so of course I need it for 27 degrees and 11 minutes. So I'll go into the column of 27 degrees. So this is where 27 degrees is. So you can see here 27 degrees is horizontal. Now because I don't have 11.7 minutes, what I have in the vertical section is 11 minutes and 12 minutes. So I will note down the values of 11 minutes and 12 minutes from the Norris table. So at this point of time you can pause it, you can look at it and see how I'm getting the values. So I basically went in the column of 27 degrees, and then horizontally I traced the row of 11 minutes, and I did the same with 12 minutes as well. That's how I got the values. Alright, so once you understood how I got the values, go back to the calculation here, and you can see these are the values I got from the tables for 27 degrees 11 minutes and 27 degrees 12 minutes. So I'll have to do some interpolation to find the value for 27 degrees 11.7 minutes. So I can see that as the value has increased by 1 minute, that means 27 degrees 12 minutes minus 27 degrees 11 minutes. As I have increased the value from 11 minutes to 12 minutes, that is an increase of 1 minute, the value of MP has increased by a value of 1.12. What is this 1.12? This is nothing but the difference in the MP values of 27 degrees 11 minutes and 27 degrees 12 minutes. So as I increase the minutes by 1, my MP value or the meridional paths value is increasing by 1.12. So if I increase the value by 0.7, what is this 0.7? 0.7 is the difference between 27 degrees 11.7 minutes minus 27 degrees 11 minutes. So if I increase the value from 11 minutes to 11.7 minutes, how much should my MP value be increased? That is what I have to find out. So I'll do a cross multiplication here. This results in this equation. 0.7 multiplied by 1.12 divided by 1 gives you 0.784. This is the value by which the MP value should increase as I go from 11 minutes to 11.7. So therefore I'll take this value and I will add it to the value of 27 degrees 11 minutes. I will add it because I can see as I am increasing from 11 minutes to 12 minutes, my MP value is also increasing. So therefore if I go from 11 minutes to 11.7 minutes, my MP value should increase. So the MP value for 27 degree 11.7 minutes, once you add the two together, you get 1685.964. Alright, similarly I have to find my MP value for latitude B. My latitude B is 36 degrees 9.8 minutes, which lies between 36 degrees 9 minutes and 36 degrees 10 minutes. So I'll go back to the Norris table. This time I have to go for the degrees of 36 degrees. So I will go here. My degrees is in the horizontal column here, 36 degrees. And I have to go into the vertical column to find it for 9 minutes and 10 minutes because I don't have it for 9.8 minutes. So I will note down these values. So I'll go horizontally until I stop in the column of 36 degrees and I get both the values here. So 2315.32 and 2316.55. Alright, you can pause the video here, look at the values carefully before you go back into the calculation. So I'll go back to the calculation here. These are the values I got from the tables. Again, I will do the interpolation the way I did it for previously. So if I increase the minute by 1 minute, that is the difference between 36 degrees 10 minutes minus 36 degrees 9 minutes. If I increase it by 1 minute, my MP value increases by 1.23. What is this 1.23? It is 2316.55 minus 2315.32, the above two values. So if I increase it by 0.8 minutes, which is the difference of 36 degrees 9.8 minus 36 degrees 9 minutes. So if I increase the value by 0.8 of a minute, how much should my MP value increase by? Because I can see the MP value is increasing with increasing minutes. So again, a cross multiplication will result in the below equation. You get a correction value of 0.984, which you will take here and add to this value 0.984, because from 9 to 9.8 the value is increasing, so I will add it. Once I add it, I get the MP value for 36 degrees 9.8. I get 2316.304. So now that I've got my MP values for 27 degrees 11.7 and 36 degree 9.8 minutes, this is latitude A and this is latitude B. Both are south. So the rule for DLAT, or rule for calculating DMP is difference in the meridional paths. So what you have calculated is meridional paths. So rule for difference in meridional paths is the same as rule for DLAT. That means if they are same names, you will subtract one from the other. Alright, so you will subtract, of course, the smaller number from the bigger number. DMP is not negative, and you will get 630.35.34. This is the DMP value. You have subtracted the MP value of latitude A from MP value of latitude B. Alright, same rules as DLAT. So same names, you will subtract the MP value from one another. If they were different names, if one was north, the other was south, you would have added the two to get the DMP value. Now that you've got your DMP value, come to the formula here. Tan, of course, equals Dlong by DMP. DMP you can get from here. Dlong you have calculated previously when you converted into minutes. Put it in the formulas here. You get tan course equals 0.68661. Take tan to the other side, becomes tan inverse. In your calculator, press shift tan and the value here. You will get 34.5 degrees. Now when you have 34.5 degrees as your course, you can round it off to either 34 degrees or 35 degrees. I leave the choice to you because it's in the middle. If it's less than 0.5, you would have rounded it off to 34 degrees. If it was more than 0.5, you would have rounded it off to 35. But when it's 34.5, you can round it off to 34 degrees or 35 degrees. It doesn't make a difference. It's up to you. I have rounded it off to south to 34 degrees. And again, I have named it southwest because south comes from DLAT, that's correct, and west comes from Dlong. But this also tells me it's south 34 degrees west. So again, from south going to west, I will be going by 34 degrees and my course will be 180 plus 34 degrees is 214. If you have chosen 35 degrees, your true course will be 215. Alright. That is why I thought I'll show you the difference here. So with plain sailing, you were getting about 34 degrees. With Mercator sailing, also you are getting a course of about 34 to 35 degrees. So no difference at all. So now you have to see whether your distance differs or not. So to calculate the distance, use the formula cos course equals DLAT by distance. This is the same formula as plain sailing. You know your DLAT from before and you know your course. What you don't know is distance, so you will take the distance onto the other side and bring your course here, which gives the formula distance equals DLAT by cos of course. Like I told you before, course you can use either 34 or 214, and if you have chosen 35, then 35 or 215, doesn't make a difference. You might get a negative value in one case, like you see here. If I use 214, I get a negative value. You can ignore this negative value, ignore it. Only for calculating distances, alright? Not otherwise. Don't ignore negative values otherwise. Only when you're calculating distances or similar like departure, then you can calculate or you can ignore the negative sign. So 538.1, which is your DLAT, cos course is cos 214, gives you 538.1 divided by negative 0.82904. You can ignore the negative and you get the distance is 649 nautical miles because you will ignore the negative sign. Now this distance is very similar to the distance that you got in plain sailing. Both are 649. The courses are very similar here as well because you can see the distance is very close to 600 nautical miles. So like I said before, plain sailing is used up to 600 nautical miles and Mercator sailing is used for distances more than 600 nautical miles. But this is not an exact figure. This is not based on an exact science. It's a random figure because you will see books quote anything from 400 to 800 nautical miles. But you can see here in the case where the distance is 649 nautical miles, the course and distance doesn't vary. So if you have to choose one of them, in this case, where the distance is very close to 600 nautical miles, plain and Mercator course and distance is the same. So it really does not matter which you choose. So you can choose Mercator because it is chosen for distances greater than 600 nautical miles. But if you say you will choose plain because there is not much difference, you can go with plain sailing. It will not make a difference. Alright, when distances get larger than this, the difference will start to occur. So I thought I'll take up this question to show you the difference between plain and Mercator sailing. It's good to know this difference and see it work out in practice, because tomorrow on the ship you should be working out in practice. So let me know if you have any questions regarding this problem and I'll be happy to answer your questions. Put it in the comment section for everybody to be able to see and know your doubts, so it might be their doubt as well. So let me know and I'll be happy to answer it. Thanks guys, and thank you for watching. All the best with your studies.